Okay, we are coming online. This is going to be a super spontaneous stream once we actually get online. Cool. It says YouTube we're up and waiting for Twitch and Facebook. There is Twitch and come on, Facebook. Or maybe Twitch is down. Looks like I am confirmed on YouTube because I just got an email. So I'm just gonna start talking. Yeah, so this is gonna be a super spontaneous stream. For those of you catching this either later or signing on now, my name is Aaron Chen, and I am a data scientist. Currently, I am about to start my new job with the Centers for Medicare and Medicaid. And there I will be working on, actually not entirely clear right now. I'm guessing that will be discussed in orientation next week. But one of the reasons why I wanted to join was because they expressed some interest in doing some natural language processing on their survey data. And I thought it'd be really cool to work on that and try to get some sort of machine learning aspect in there to help them kind of direct where to drive improvements in their service. My impression is that in the meantime, I'll be trying to help them get out of tech debt because Medicare and Medicaid have been around for almost half a century now, and they're using a bunch of technology that people might not use anymore. So yeah, I'm pretty excited to start that next week. And what I'm going to be doing now is, I guess, I'll give an update. If you don't see a lot of me, you can always find me on Instagram, Aaron W. Chen, on Twitch at Chrono015, Facebook, Composed and Focus Studios, and YouTube, same Composed and Focus Studios. And all that stuff's actually in my my timestamp in the corner in the bottom. And yeah, big updates lately. So waiting for this job to start, and I'm currently doing a lot of classes to try to kind of get me back up to ready mode. I was taking some algorithms classes, and now I'm taking one on deep learning, and it's actually the deeplearning.ai course on Coursera. And also doing some programming on the side for my independent projects, one of which we're actually looking at right now. This is Melion. So the big updates, I've been mostly doing classes, haven't been doing a whole lot of work in my projects, unfortunately, just because some of the classes are pretty cool and they are very technically challenging. So right now, I noticed this like super weird bug about a week ago when I was still working on my projects. Yeah, there's a lot of gray in my GitHub right now, not a lot of activity recently. I noticed this like really weird bug where my local Visual Studio Code, which you can actually see, it's brought up right now, it basically wouldn't acknowledge Git activity, and it was really odd because if I used Visual Studio Code Remote into my my headless Pi, my Raspberry Pi, it did actually recognize Git activity, but for some reason locally it just wasn't having any of that. So yeah, and I signed in just now, and it says, "Hey, you got 77 updates," and I honestly don't know what's different because I had thought I had mostly been doing Git commits either in the terminal or on my Raspberry Pi, and I just checked GitHub right now, and everything seems to be up to date. So I am really wondering what is going on with these 77 changes. So what we're going to do right now is we are actually going to pull from mastered, or at least we're going to fetch, just to see what is actually happening. Definitely should not have been so far behind. So let me see, fetch from... I was expecting some other thing to pop up to ask where I wanted to fetch from. But yeah. Anyway, so right now this is not actually showing this. Okay. Well, we're gonna pull. Um, this is a scraper. Um, how is it going? Thanks for checking in. This is a scraper for my Melion project, and where I had gotten it last week, last time I signed in, was I was successfully scraping allrecipes.com. And they have a nice feature with their world cuisines where they have various, what's it called? Cuisine tags. So they had French, they had Mexican, Chinese, Thai, et cetera, et cetera. So I was scraping those tagged cuisines, and I was basically trying to add those to a database on SQL locally. And I did have success. I finally got everything to work, and I fully scraped almost all of the tagged cuisines. The only issue I was having was that I noticed that at least one of the recipes was a repeat. So I found they had Canadian cuisine, which I definitely thought was really cool because I don't know a lot of Canadian cuisine. But unfortunately, when I actually looked at the recipes, they actually had like a Mexican taco seasoning flagged as a Canadian cuisine. And I think it was because the author of that recipe was Canadian. And all right, just putting stuff in chat. Yeah. So because of that, it made me rethink my whole data pipeline. So right now, I'm scraping everything and putting it into one unified SQL database for all recipes, and then just basically just individualizing the adding a cuisine tag in there. And honestly, I don't think that's the way to go about it anymore. I think I'm going to refactor these scripts so that what they'll do is actually put them, it is way more tedious. It's going to put them into their own individual tables in SQL, and then I can link them using the primary keys, the ID numbers as primary keys, and just to see if there's any overlap. And if there's overlap, I can deal with those situations when those come up. But right now, we need to figure out what is going on with SQL. So let's pull from master on origin. And hopefully that doesn't screw up a whole bunch of stuff. But it is very curious why we have all of these changes in here. Yeah, it's really weird. And I did notice that like I'm going to start refactoring these so that the code is a little bit prettier. I have a couple things like using comments to denote basically notes. And I think I would actually prefer to use Google Style Sheet. I have a separate, so I have a monitor up here that has the stream, and I'm noticing that there's actually like a big lag. So it is kind of cool to see. It is way behind. I'm just kind of surprised at how far behind it is. It is also a little bit stuttery, which is unfortunate. I am currently in the market for building a new PC and basically a new desk and a whole new room. And I am really looking forward to getting that to work because, man, using this laptop is great, except it is a little slow for what I want it to do. And honestly, the screen is a little too small. A 13-inch screen all day is pretty difficult. But yeah. So what we're going to do, I will actually load it on here and put it in the chat. What I'm going to do is put Google's Python style guide in chat. And I think these are honestly like really good things to follow. Let's see. This is actually not the same style guide as I had before, but what I want my code to look like. But it is something that I am going to try to do in the future because I really like the in the comments they make it explicit, like what is going to be fed into each method or function, and then explicitly saying what they want out of it. So Python has stuff like this already built in with, I believe it's 3. Did it start in 3.7, 3.6? There is some aspect of static typing in Python now, and I think it's really useful and helpful. And it just makes like troubleshooting a lot easier, to be honest with you. So yeah, unfortunately, I actually am not sure how it handles situations like this, where some of the objects I'm exporting out from various methods are not basic Python classes. So I don't really know what's going to happen. Definitely on my, actually, I should put that on my to-do list. Let's see. What I would want to look up are things like scrappy objects and static typing. Because if I can get these things to kind of work, I would actually like to do some more test-driven development. Yeah, I would like to do some more test-driven development because, like, in doing all of this, like, very iterative process and the way I'm doing things, it is good for one person to do, but it's like very difficult to work with multiple people or even just with myself later. So now that it's been a week since I've actually looked at these things, I can tell that there's going to be things that I just honestly don't remember anymore, just because I've been working on other projects or other class stuff, and my technical mind has been split somewhere else. So basically, one difference that the Google style sheet recommends that I'll just throw in here right now is for these multi-line comments, instead of having these separate what are they called? Octothorpes for comments. You can just do multiple lines with triple quotes, which is honestly preferable because it makes it very clear that they are going to be triple quotes. So in here, I actually have notes. So I have what the method is supposed to do, and then some issues I've noticed when I was doing these things. This is probably not ideal to put the notes in here, but it is helpful for me later. It's kind of like almost like a sticky note. Like once I actually fix it, I can just delete it from here. Yeah, so, oh, I'm remembering some of these issues now. Okay, cool. Okay, well, what we're going to do is, this is Epicurus. So I don't need to do Epicurus right now because that actually works. So yeah, I scraped Epicurus and that was fine. I can actually log into my headless Pi, which I'm going to do now. And let's hide my password. Let's retry connecting to my headless Pi. I'm going to make sure that I actually pushed all my changes from my headless Pi to my GitHub. And hopefully I didn't just give myself a merge conflict, because that would be extremely annoying to deal with. Okay, cool. So on a different... is it a different one? Let's see. Huh, that's weird. Okay. So, oops. So you can't see it. So it's super weird. You can't see it, but I'm actually looking at a different Visual Studio Code window right now. So this is the one that is visible to you, and I'm actually dealing with one that is different, but you can still see my mouse cursor, even though I'm totally not using that one right now. Really weird. Okay, that's cool. But I'm going to make sure that all my... Okay, so those got pushed. Let me actually look at my Git commit history. Yeah, I know this isn't the most exciting thing to look at right now, but let's see, 49 closed. Yeah, okay, so everything is up to date. That's cool. Let's see. So what I can do now is, now that I know this is synced up, I can just work on stuff in this one. Okay, so, right. Make this change, put this here. That's a string, that should be okay. Put it in the headers. Yeah, I have notes here. Okay, so this method is based on the template from Scrappy. Currently, it needs a way to figure out how many pages there are in the pagination so that it can stop scraping intelligently and without user input. Let's see. Okay. So we can see that I tried to do a page, basically make it go until true, or while this is true, but I need a way to actually denote something is false. Okay, yeah. So right now, the way this works is it will just scrape, and then I just go to bed, basically, and then I check in a few hours later, and then I can see whether it's done or not. So it's not ideal because it will ping the server with a bunch of requests, even if that page doesn't exist. And I thought I had put in this logic that said, hey, if it actually hits a 404, just stop. Apparently, it doesn't do that right now. Let's see. So I have print 404, and then I need to break the if statement. So let's look at some documentation. If true, stop. Oh, that is Excel. I don't want that. Python. How to exit if. Okay. Let's try just return. Yeah. Okay, cool. Hopefully that will fix it, but I'll just look at it later. In the meantime, I really wonder what all of these changes were. Let's see, untracked changes. Oh, wow. This is Asian cuisine. Oh, wow. I didn't add any of these changes to Git. Okay. Add Asian, European, add missing cuisine tags. That's right. I think I wrote all of these scripts and then didn't add them to my Git commit. I was like, oh, okay, well, I noticed the logic where like I had an issue with the duplicate entries, and I was like, this is definitely something I'm gonna have to fix later because like things like this Asian cuisine and European are umbrella cuisines, and there will definitely be overlaps right now. Yeah, and the way the logic works is it will look for the unique ID and then basically, if there's an overlap, if there's that already exists, it will just update the data that's in there. And it was supposed to help fix like maybe there's like mistakes with a previous scrape, or maybe I just wanted to get more data from a new scrape. Yeah. Okay. Cool. Good to know. So I'm going to stage all of these changes, and I'm going to commit all of them. So that's going to be almost 80 changes that I definitely should have committed last week when I was working on this. That is my bad. Yeah. Let's see how long that will take. Okay, cool. They're all staged. Gonna commit all of them. And I can push them. Do, 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 do. This is taking a while. Yeah, so right now I'm actually streaming via Wi-Fi, which is like kind of brutal. Why is this not? That should be also staged. Forgot add logic. Oops, logic to stop if true. Okay. So I'm streaming off Wi-Fi, so that I wonder if that explains some of the lag and some of the choppiness. Normally, I stream to another PC, and that is the one my desktop, and that is the one I'm trying to replace. It is currently dying pretty fast, and it just crashes, so that's not fun. Okay, cool. So push into origin. And I should see that on GitHub somewhat soon. And then I'll just think about that later. So what I've got, let me think. Where is my, oh, I don't have my dice handy. So what I want to do is not do this one right now because it is a little tedious to write the scripts. I think what I'd like to do is show off something that I had done already. Maybe I can update it because I did see some logic problems. Yeah, and that'd probably honestly be like a more interesting stream. And I can explain some statistics. So yeah, why don't we do that? Let's see. We are going to try to find where I put Melion database. Okay, so let's make a new window. And we are going to open my Melion database project. So for Melion, I actually split different parts of it to try to make it a little bit more modular. So what I'm doing right now with the scraper, technically the scraper gets a bunch of data for the database. And the database, I had actually, out of very curious to try this, I took a different database that was scraped, and I basically tried to do some logistic regression on it. Basically, what I was trying to do is that the database had a bunch of flag data, like tag data that said like, oh, this is like Indian cuisine, this is Italian, and I wanted to try to predict based off of the ingredients that were in there what the cuisines would be. So this is actually on a site called Kaggle.com. If you don't know Kaggle, trust this notebook because it is mine. And what they did was they had a contest that said, okay, given you have these recipes, can you make a good prediction for what the cuisines are? And I was inspired to write something like this because it was good practice for a bunch of interviews I was doing, and I read frankly, I mentioned this I think in my last stream 2 weeks ago. I found a not particularly well written article talking about this particular data set. it was missing. We'll go over why it was a problem, but basically, it was yeah. So I decided to try to write my own notebook to try to explain what was going on and see how well I could do something. So we're going to walk through this notebook. It is currently running in Visual Studio Code. Why isn't this kernel attached? So we're going to pick a kernel. Let's pick this one. That is not the kernel I expected it to use. That's fine. But let's walk through the cells. So in this first cell, we're actually going to... oh man, I forgot how different it is to write in Visual Studio Code versus in the Jupyter Lab notebook. I'm so used to muscle memory with my shortcuts. So I'm going to insert a cell that I actually wanted up top. And this is going to be a markdown cell. Oop. How can I change this to, oh gosh. Come on. Change to markdown. There we go. Oh, you can't see it. That's right. So let's change the window. Window capture. Yeah, that's the one we want. Cool. And we are going to. Oh gosh, that's not how we wanted it set up though. Cool, 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 cool. And make this bigger. Okay, cool. Let's see. We need... Yeah, that's definitely not the... kernel I wanted. Okay, well, what we're going to do is, why? We're going to struggle to write anything in here. Gosh, okay. Let's delete this. We're going to delete that, and we're just going to pretend it's markdown right now, and then I'll change it later. So basically, we're going to do import necessary libraries in this section. So make this a double heading. Oops. And change that to markdown. Shift enter. And then below this one, we're going to put another code cell, and we'll put a divider markdown. Shift enter. That'll divide it nicely. Below this, put another, let's see, import data and convert to markdown. Cool. So what we've got here is, preview the data. Dang it, I did it again. Let's see, preview. As imported. Preview raw imported data frame. Oh, dang it. I shouldn't have done that because now it's thinking it's gonna, there we go. Yeah, cool. Let's stop the kernel. Should be markdown. Okay, so we'll just walk through what happened because technically I already finished this one. And I think going over this will help explain some of the statistics and stuff. So code-wise, these are libraries that like I'm used to seeing / using. Basically, they're pandas, which allows you to do data frames. Data frames with pandas are kind of like Excel on steroids. And then I've also imported NumPy, which is a vector math essentially. There's like a bunch of stuff that pandas depends on in NumPy, and some methods that are easier to call directly through NumPy. I've also imported iter tools. I actually don't remember exactly why I used that, but it's a built-in library, I believe, with Python. Maybe not. And then the big one is scikit-learn. So scikit-learn is a very big library, very popular with data scientists and statistics people. And there's a bunch of different sub-modules or sub-libraries with scikit-learn. And I've imported quite a few of them. So like for pre-processing the data, I've brought in label encoder, and that's because there are 20-ish cuisines that are labels, and they have to be converted into things that basically can be used by a computer, which is math. A computer may not be able to handle something that's like, oh, this cuisine is labeled Chinese, right? Because like that doesn't necessarily mean anything to the computer. It would prefer some sort of numerical representation. So I've also imported model selection, and from that I wanted the Stratified K Fold. So what Stratified K Fold does is it will take a data set and split it up into different folds, basically, different subsets, and the number of subsets is K. Now, I have also picked stratified because the data set is actually imbalanced. So if I remember correctly, there's a lot more Italian recipes than anything else. So I wanted to try to split the data set such that it would always have like the same proportion of recipes in each of the subfolds of data. Yeah, that one is kind of cheating a little bit, I guess, because one of the reasons why you'd use K-fold is to try to avoid overfitting your model. And basically, if I'm stratifying it, I'm not entirely sure how much different each model is going to be. And it might end up causing some sort of overfitting, I guess. Actually, in hindsight, I should have just done a regular K-fold as well. All stuff that I guess I can write down. So I'm going to put, let's see, also try a baseline with regular K-fold. And let's see, I've also brought in feature extraction to try to basically convert these, what the purpose of this project or challenge was to essentially take the ingredients from each recipe and create a machine learning tool that would like tag the correct cuisine based on the ingredients. So again, computers can't see words, so you have to convert them into something that kind of makes sense. So in this case, it makes sense to computers. So what I've done in this case is I actually imported something called that is TF IDF vectorizer. So what that means is term frequency, inverse document frequency, and it makes a vector. So that's a lot of words. So vector is basically just math stuff. And TF IDF is the term frequency inverse document frequency is a way to essentially measure the occurrence of words and downweight words that appear a lot. So in this case, the recipes will probably all have salt. So if I'm trying to judge what a cuisine should be based off the ingredients, if every recipe has salt, then salt is not a very good indicator of which things are important because it shows up everywhere. So you could actually use like something like one-hot encoding and basically just says like, does this exist in this recipe list or ingredient list? And if it does, count it. But in that case, like it's not particularly, it's like a pretty naive model because there are going to be there are going to be things, rarer ingredients to particular cuisines that are much more important. So if I were to do a one-hot encode, salt would have the same weight as like Sichuan peppercorn, right? And like Sichuan peppercorn should be kind of a giveaway that it's Chinese food. So giving them the same weight is a little unfair. So that's why I've actually used TF-IDF so that like if there are things that show up all the time, basically it just tells the computer like don't give these as much of a weight or importance when trying to figure out similarities or classification. In this case, I've also brought in a linear model for prediction, and it's just logistic regression. Since I'm just doing classification, this is the simplest way to do classification, although this is a more difficult version of it since it's multi-class classification. Normally, logistic regression does really well with binary, but in this case, I'm asking it to do like, hey, pick one of 20 cuisines and tell me which one it is. So yeah, there's a lot of like behind the scenes questions on like, well, what is the method for it to pick which one is the right one? But we're not going to go into that because it is like in their documentation. It's actually like pretty well written, but it is kind of dense just because like you can pick a bunch of different things. I've also imported metrics because I wanted to see how my model did. So I imported giveaways like, or given easy ones like accuracy and precision recall. And then I asked for F1 score, classification report, confusion matrix, and then the area under the curve score. So these are actually more difficult to explain. So accuracy should be pretty obvious to you. Like that's, and we can let's look up these actual statistics definitions of all these things because they have very precise meanings. Stats, definitions, and I don't want to get these wrong. Accuracy, recall. Okay. So, yes. Okay. So, with accuracy, I think accuracy score. Let's see. sklearn accuracy score. Why am I looking at that? I want to read the actual documentation. Yeah, so actually, that's pretty cool. So this is what I just read. And because it actually has a shout out to multi-class classification. Yeah, so basically what it's going to try to do is tell you in their example, it's like, how many of these did you get right? So this is honestly like pretty naive way of judging how well your model did, because in an extreme example, if you had a very imbalanced set of data and everything was like 99% no. So let's say there's a rare disease, right? If the overall data is like 99% or overwhelmingly in one class, then your model would actually do really well if it just picked the overwhelming majority. It would be accurate almost all the time. So accuracy is not actually like maybe the best way to show how well your model is doing. So the other things to look at are things like precision and recall. So recall is basically how many true positives did you call versus how many things that you called positive. Hold on. No, sorry, that's precision. So how many things did you call? How many things did you actually get as true positive versus over the sum of how many things you got as true positive and how many things you called positive but were actually negative? Recall is slightly different. It's the number of things that you called positive the number of things that you did get correctly as a true positive over the sum of the number of things that are true positive and false negatives. So these are all like kind of important metrics. Recall is also known as sensitivity. So I actually don't remember why they have multiple words for this. But when you're looking at your true positive rate, your precision, I believe that influences your your type 1 error, I believe. Wow, it's actually been a really long time since I looked at these statistics things. Oh, I always got to remember to review these. Man, the thing with statistics is like, unless I'm using them all the time, I am going to forget. And my model and right now I'm doing a lot of scraping projects, and I just haven't been actually applying my stats knowledge. Um, yeah. Okay. So basically, if your precision should influence your type one error, yeah, and then your recall is indicative of your type 2 error because it shows like how many things you missed. Uh, okay. Um, you know, I'll go over these in a second, but the F1 score is actually the geometric mean of the two of them, and it's a little bit more. I think that one will actually show your how good your model is, especially when things are imbalanced. Okay, so let us look at the definition again. Um, if you had perfect recall, you would have no false negatives. If you had perfect precision, you would have no false positives. A recall is the complement of the type 2 error rate. Yeah, okay. And then precision is related to the type 1 error rate. Okay. So let's move on from that. And then I also imported some matrix decomposition stuff and plotting. So how the data actually looked before importing it and putting in data frame, you can see there's like an ID number for the recipe, the cuisine that has been flagged, and then the ingredients that are in there. So I wanted to actually count how many of each recipe there were. So what I've done is, that's weird. Oh, this is not the right method for what I'm doing. Basically, what I wanted to do is like, okay, actually this is fine. I said, okay, count all of the recipes or the records that are in the data set, and then just group them by their cuisine and kind of just tell me how many there were. So in this case, like these numbers match because this is just the number of records for each cuisine. So I think initially I thought like, oh, maybe there's like this many ingredients. I'm like, that doesn't make any sense. Yeah. So in terms of targets, I actually decided to split out because from the training set, the cuisine from the data frame and put that into targets variable. And the recipes are just going to be the ingredients. And I set the index to be, actually, in this case, it wasn't important. So I didn't use the index at all because there's no way to get these recipes back later. So I did a stratified K fold. I want to do 3 folds. And basically what that means is like there's going to be, it takes the original data set, splits it into 3, trains the model on 2 of those pieces, and then tests how well it does on the 3rd piece that's untouched. And then it will actually do that for the other 2. So it's like there are 3 folds, train on sets 1 and 2, test on set 1 or set 3. And then train on sets 1 and 3, and then test on 2, and then train on 2 and 3 and test on 1. This is kind of a way to get a little bit more, a little bit of a better model before actually throwing your test data at it. And in this case, the test data turns out is not helpful because the test data has no flags. So there's no actual way to see how well you did on the true test data. So I didn't know that until looking at the actual data itself. But later on, when I realized what was happening, I essentially I think I ended up essentially reserving one set to keep as like what was originally termed my validation set. I kept that out, and then I actually just trained on that. Yeah, so the article I read turns out like didn't acknowledge that was actually what they were doing. So they didn't use their test data at all, and what they actually did was they trained their model on what they had reserved as their test data, which is really bad in terms of like how well does your model do, because you've essentially trained it. What that actually means is like, imagine you're studying for a test for anything, right? You want to practice a bunch of problems so that you understand what you have to do, the knowledge that you're being tested on. You have that in your head, and the mechanisms to try to get the answer, right? By splitting the training and the testing data, you essentially have like a bunch of problems that you've never seen before as your test set, so that you can keep practicing on older problem sets and then see how well you do on like ones that you've never seen like the solutions for. What this article did was they essentially had the answers worked into their what they're studying, and then said, okay, well, how well did I do on these problems? So like, it's kind of like if you've taken open book tests before, and you luck out and the problem that you get on a test is the same exact one that you got on an open book test. Like logically, you would do way better on that problem because you've already seen it, you already know the answer, and you may even have the solution ready, right? So this article essentially did that with their data, and then said like, oh, look how well our model did. And it's like, well, that's technically not correct, and that's a big problem called data leakage. So the one thing I messed up here is that instead of actually testing the performance of each individual K-fold, or subset of the K-folds, I actually only got the scores for the final one, which was like really silly. But something that I know I need to fix. But I'll walk you through still like what's actually happening. So created a stratified K-fold and then said, okay, we'll split these such that I get training sets and a validation set. And the validation set is the one that like you should train the model on or test the model on. And then the separate test set, we'll look at that later. In order to actually get things working, I had to use that label encoder. And the reason why is because these labels, like Brazilian, British, etc., don't really mean anything to the vector math. So label encoder will essentially take all of the classes that are in the targets and convert them into just numbers, like 0 through, I think there's like 0 through 20, we'll say. I can get back what those classes are. Like, it hasn't forgotten them, but in terms of like what this data will see, it's just going to see like numbers. So I then used that to transform the target matrix, and you can see here like this is the original set of tags, and then this is what those were all converted to. So it's just like 6, 16, 4. But if you inverse, you can get back to original cuisine, which is human readable. So after that, I decided to make an overall corpus of all of the recipe or all the ingredients that are in the total sum of the recipes. So in this case, I said, okay, well, I need a double for loop, and I used a list comprehension for this, but it was like, go through every recipe. Let's see, go through every recipe in the training set, and grab the ingredients, and then basically take that list and put it into one, compile it, all of them into one big list. So yeah, let's go through this, this list comprehension with 2 4s in it. So it's going to say, okay, this is an item in a recipe. Now go get all the recipes from the total sum, the total amount of recipes, and then just put all of it into one thing. So instead of say, where is it? Instead of these, as you can see, like each thing was a list. Just extract the value and then put them into one mega list. So here it's like the first 5 elements are lettuce, black olives, grape, tomatoes, garlic, and pepper, which turns out like that is most of the stuff in the first recipe. So that makes sense. All words has everything, and then the length is there's like 285,000 ingredients in here. So I needed to convert this into math. So I use this method called TF-IDF vectorizer. I'm realizing that I actually wrote up a whole process on this when I was actually doing a lot more of this stuff day to day. And it's on my Medium blog, which I wrote for analytics video. And it explains like the walkthrough of like why did I do these things. But TF-IDF essentially, I fed it a token pattern with a regex and just said like, okay, you want to get rid of, essentially ignore uppercase and lowercase. And I think you want to get rid of any ingredient that is shorter than 2 characters because that's probably a typo. And then I said, okay, well, I only want to do unigrams. So I want single words. And those are the things I'm going to base this first model off of. So I said, okay, fit all words using a unigram. So that was implied. Basically, I'm just saying like count every word individually as a thing to vectorize on. And then transform the actual recipes into this huge array where all of the columns are the individual recipe ingredients. So you can see here, like once I've gotten it, it's like, oh, here we have 26,000 recipes, and it's kind of like abalone, abamel, absinthe, abora. So this is like pretty helpful. It's a mostly sparse matrix, which means that almost everything is 0 because not every recipe has every ingredient. But you can see like by picking unigrams, you have only individual words, right? So acid, for example, shows up. But do you add just straight acid? Technically, you do, right? But you're doing it in a way with like acetic acid, so it'd be like vinegar, or maybe you added what's another common acid you could add? Actually, I can't remember what ingredients would explicitly call for acid, or what recipes would explicitly call for acid. That's interesting. But yeah, so interestingly, it kept this ingredient ZA. I don't know what that is. But going through here, you can see there's like almost 2,800 ingredients, and they're all just individual things. So unfortunately, there won't be things like olive oil or black pepper, right? Because like those would be split into olive and oil and black and pepper. So one thing to work on after this would be like, well, what if we tried bigrams? So you could have olive oil or black pepper as one ingredient. All things that like just more tweaking and more iteration. So here, why did I do this? Oh, basically I was trying to figure out if this is the word matrix. I wanted to see, let's look at 20 random words later. And it's like, oh, well, these are the things that showed up. And this is a good example, right? Like here, like black shows up, but it's like, okay, does that mean for black beans or black pepper or what exactly? So this is a little bit of this could use a punch up because this is not a particularly helpful word in terms of ingredients. It's missing some context, right? And also there's a error here. It's biscuit and biscuits. Normally, in my other project, I have a tokenizer, which would actually convert this into just one thing because, like, how different are biscuit and biscuits? So that's interesting. Same with like blackberries and blackberry. Like those should be counted as one thing. So there's actually I will put that in here. Let's add a new cell. Let's see. punch-ups, add support for bigrams, trigrams, maybe quadgrams. 2, tokenize or lemmatize words. Yeah, it should be lemmatize, not tokenize. Tokenize is when you just convert it into a numerical thing. So lemmatize ingredients to remove plurals and duplicates. Yeah, and that might also fix some spelling errors that are probably in there. So we added that. Yeah, so now I'm actually walking through and just saying like, okay, well, for this first recipe, what are the ingredients? And it's basically almost nothing, right? Like nothing, no abalone, no absinthe. So there's a way to filter down to just show like, oh, what are the things that are actually there? So I said, okay, well, I still want the first recipe, but I want the first recipe from the matrix, but I only want the values where it's greater than 0, which means that there's some sort of ingredient there. And you can see here like beans, black, cheese, crumbles, feta, garbanzo, like these are all the things that are in here. And I think this is that Greek recipe just based off of feta, garbanzo, and olives. So this is interesting, right? Like we can see that there's some faults in the way that the tokenization happened because like, again, black here probably goes with black pepper because it's a Greek recipe, but those things shouldn't be considered separate. I have no idea what seasoning means. So that's interesting. And then like cheese and feta also probably go together because there's no real reason for them to be separated in this context. But you can see that like this number here is essentially the vector value for this ingredient. Yeah, so I basically said, okay, well, let's look back at what the actual ingredients for this recipe are, and we can see that actually I was wrong. So black here went with olives, not with pepper. And this makes a lot more sense. Grape tomatoes, grape is a little odd to have in a whatever this was, and it was feta cheese crumbles. Okay, so you can see the value of like why it's important to consider having bigrams and even trigrams here. But for a first run, I just said, okay, well, let's do let's do a logistic regression to try to solve, and we've got a multi-class problem. We want to tell the regressor to balance everything by itself as well, so that we know that the data it feeds in is going to be imbalanced, but we want to make it so that like the more frequently appearing things get penalized for showing up more in predictions to try to give all the classifications some equal playing field. And here I said like, run this 1,000 times until to see if you can do better. And then I picked a random state so that this is actually repeatable. Yeah. And then I fit everything here and then did a prediction and then made this function to get the actual scores out. So precision score, recall, F1 score, and then return them in accuracy and return them all as one thing. And then said, okay, well, now give me back the answers. And in this case, like I had a accuracy of almost 82% and F1 score of 0.82, precision of 83%, recall of almost 82, and that's all on training data. So it's like, okay, well, that seems pretty decent. Then I basically did all the same transformations. I should have actually functionalized these. Did all the same transformations to what turned out to be the actual, like our validation set, but it was our test set. And then predict the values, and then see how well it did. And in this case, on data that the model's never seen before, it did somewhere in the order of like 76%. So that's okay. for a first run, that's pretty good, I think. And obviously, things can be improved by incorporating like bigrams, trigrams, et cetera, et cetera. So yeah, and this is the part where so this is my validation set, and I went cool, 76% on data it's never seen before, but already labeled. That's awesome. Let's look at the test data. And then this is the part where I realized that like the validation set that I separated from my training data turned out to be the actual test data, because the test data is given by the contest providers. You can see here there's an ID, ingredients, and then no cuisine tag. So there's actually no way for you to know how well you did. So with the actual competition, they took your submissions and then judged how well you did because they had the answers, but they never provided those for people after the competition ended. So to be honest, their test data as provided on Kaggle is like almost entirely useless for these purposes because like you have no idea what these things are. So just looking at the first two recipes, like baking powder, eggs, flour, and I guess raisins, that could be cinnamon bread, it could be babka, it could be a number of things I'm thinking of that are just baked goods. Second ingredient, second recipe: sugar, egg yolk, cornstarch, cream of tartar, a custard of some kind. But the cream of tartar kind of implies that like later on there may be egg whites and they're making a meringue. And I'm not entirely sure what the cornstarch would be for. Third one: sausage, fennel. They split this ingredient. Fennel and olive oil, like to me, reads as Greek. But it could be a salad, it could be just Mediterranean food. And then this one looks like, oh no, I can't believe I forgot the name of it. Gumbo, because of the meat cut, filet powder, smoked sausage, and okra. But it could also be, actually, I don't think that's anything else. That's gonna be Cajun Creole. Yeah, so like because you can't actually see how well you did on their test data, I just said, okay, well, screw it. I'll just look at the confusion matrix. And in confusion matrix, what it does is it tells you, well, this is what the model predicted, and shows you like how well you did comparing to the actual ground truth. And because this matrix is so big, it's a little bit difficult to see the results overall. But on this axis, on the y-axis, is basically like the actual value. And then on the x-axis here is what I predicted. So what these numbers say is like, okay, let's go with the first one. The first one's Brazilian, true, and it means I have 261 like true Brazilian things. However, I also predicted, in this case, 5 true Brazilian recipes as being British. Oh, that's weird. I kind of wonder what the ingredients were for those. So yeah, and you can just go through. With the smaller matrix, is a lot easier to see and understand. With 20, it's a little difficult. Yeah, but that's basically all that was happening here. And then on the validation set, similar things. And then this is where I realized that like, oh, the test data is useless as well, because I couldn't actually get, without a ground truth, you can't do a confusion matrix to compare how well you're doing. So that's why this function doesn't work, because it just says like, basically have no idea what you're looking for. I had made a method that basically also grabs the most important ingredients for each cuisine and then actually plots them. So I'm not sure if the plots are actually here because this notebook didn't fully render. What on earth? Okay. I don't know where those plots went, but yeah, that's basically all this was. And there's things that can be fixed. Yeah, and even last time I did this and showed my brother, we actually have notes on like what did we talk about to try to fix this thing. So yeah, I've been going for an hour, and I think it's dinner time. So this is stuff that I want to basically show that like what had happened, and then I'm also going to write. I wanted to write an article for this to explain, an actual kind of work process. But I'll keep playing with this. I'll do similar things with my own data set once I've kind of touched it up a little bit, and just to see how well things predict. This particular data set with 26,000 recipes and 2,000 ingredients is in that range where it's small enough that I can get away with this kind of model. There's another fault with that article before where basically they just dove straight into using deep learning and built this neural network to do the classification. And in that case, like it was actually worse than this thing. So they did more work to get worse performance, and they were technically cheating because they did data leakage. So it will be interesting to see. I don't think if I improved this logistic regressor and then built like a neural net to do the classification, I honestly don't think that would make things better because there's just not really a lot of data for this to process. Later on with all of my scraped recipes, like I scraped food.com, which is like 500,000 records. On that data, I think a deep learning set would actually be much better. But for this right now, I think it's fine with a logistic regressor. So eventually when I mash all the recipes together, that'll be the thing that I look at. So yeah, I think that'll be enough for today. If you have any questions, feel free to ask me. Definitely revealed that I need to, again, review my stats knowledge because all these things I have cheat sheets for, and I'm like, oh, okay, I'll just look it up. If you have any questions, reach out to me on Instagram, Twitch, Facebook, or YouTube. All the links are there in the bottom right corner. And I mean, you found me on Twitch, Facebook, and YouTube, otherwise you wouldn't be here, right? Yeah, if you have any questions, feel free to ask. And I would love to see if y'all are doing anything or if there's any data that you would like me to play with. In the meantime, stay safe, take the stairs, wash your hands, and wear a mask. And I will see you next time. All right.